Welcome all to Group 12 presentation of Ayurvedic Nadi measurement and diagnostic system Pajio. Nadi Pariksha is non-invasive ancient technique used to traditional and modern meditation. An experienced Ayurvedic doctor can accurately diagnose a disease by Nadi Pariksha. Pulse diagnosis is subjective and objective analysis. First we got the product, simple doctor wearable. This is for reliable acquisition of Nadi using piezoelectric sensors, which has good dynamic response and active sensors. Our old system needs to identify the features of pulse, determining accurate signals of Watha with the kapha, analyze them to verify the connection between the pulse signals with different age groups, and recognize the diabetic conditions.
Okay, I will talk about the innovative ideas of our product. First one is, in our product, we use rechargeable battery to power up the device. Because of that, the product become more reliable, very easy to use and more durable. Since we use the rechargeable battery, we get peak performance at all times from our product. Therefore, our product can use longer time. The next one is the sensor part is placed at the finger gloves. This will more easy to get measurements from the patients, and also it is more comfortable for the patients. The next innovative idea is we create a mobile app for the product. From this feature, we can keep the history of the each patient and other details of the patients. These informations might be helpful in the future when taking a decision about a patient. This mobile app can be very useful. Furthermore, we use LED bulbs to indicate the measurement taking and charging mode. And also we have an idea to connect the device to Wi-Fi. Those are the innovative ideas of our product.
I'm going to give a brief explanation on the circuit design and hardware arrangement of our project. Our project consists of three sensors: signal amplifier, a keypad with several keys, ESP32 processing board, OLED display, voltage regulator, and a battery power supply. When talking about ESP32 board, it consists of 5V USB to UART bridge, 5V power on LED, and dual-core 32-bit microprocessor. The programming of the ESP32 board can be done easily by connecting the board to the computer. The specialty of this board is handling the board using Wi-Fi or Bluetooth. When talking about the sensor, piezoelectric sensor was used to obtain the Nadi signal. As the Nadi signal was very small, we had to send it through an amplifier before sending it to the processing board. There are two powering up methods for this device: battery power supply and micro USB power supply. Battery power supply should be regulated due to the usage of lithium batteries. The OLED Arduino display is used for output.
Let's see look about our mobile application. This is an Android-based mobile application for store patients' data and other information such as prescription given to the patients and progress report. This has mainly 5 screens. First one is the study screen. In here we should connect our devices to this application. And standby mode, information adding screen, readings, and finally the notes and informations after the examination. Let's consider about the problems and solutions. The long time use. Since this is a wearable device, the doctors should have wear this device very long time. So this have to be very comfortable. So we choose this kind of configuration as shown in the photo. Then the sensors can be damaged. Since this is wearable devices and the piezoelectrics can be damaged, so this should be removed and replaced. So we use mini SMP connectors with gold plated because to minimize the low noise. Since this is the wearable devices, we are using the rechargeable battery because it can easily remove and replace and environmental friendly. Next, we use this as IoT, so we use ESP32 module as our primary module. With this, we conclude our project. Thank you.